Okay, so in the last video, we were in section 1.3, and the thing we were doing is we were taking 2 points on a line that approximates a curve, and we were kind of using the slope formula over and over and over again. And we can kind of streamline this with this formula called the difference quotient. And so actually, I actually wrote it wrong. This right here should be an x. But the difference quotient gives us the equation for calculating the slope by moving right h units from the point x. So I want to kind of draw a picture of this. So I'm going to call this point the point x. So this is the point x, and notice it's on the x-axis. So that's confusing, but it's kind of like the standard confusing thing that everybody does. So maybe someday we can fix that. So I've got a point on the x-axis, and I'm supposed to move right h units. So let's just say this is h units. So that gets me to the point over here. So this is kind of weird for people, but since this point right here is the point x, that means it's x units away from 0. And then I already know that there's h units that I moved right h units, which means this point right here, the second point that I drew, that's x plus h. So take a moment and think about if that makes sense to you, and if it doesn't, post about it on the discussion board because you're probably not alone. This is a really weird thing. So I've got this point on the x-axis, and then I moved h units to the right, and I got to the point x plus h. Now both of these points, we're going to find their coordinate points on here, on the curve. So I got to draw up here. So get these 2 points right here. And this first one right here, that's f of x. Oh, sorry, I'm almost getting it backwards. This point right here is x f of x. So a lot of times people think of f of x as meaning y, which is pretty close to what it is. So then this point up here, the x coordinate is x plus h. And the y coordinate, we would just plug it into the function, so that would be f of x plus h. Okay, so again, think about if this makes sense to you. If it doesn't, ask about it on the discussion board. Okay, so I've got these 2 points, and then let's read our definition again. The difference quotient below, that's this guy right here, gives us the equation for calculating the slope by moving right h units from the point x, where h naught equals 0. And so that I'm talking about the slope of the line between those 2 points. So we know how to calculate the slope of a line. That's y2 minus y1 over x2 minus x1. So we're going to do it this time with the weird letters that we've got. So y2 is f of x plus h minus y1, which is f of x, all over x plus h. Remember, we're doing x2 now. X plus h minus x. So notice this is going to simplify. X plus h minus x, the x's simplify. So we get f of x plus h minus f of x all over h. Okay, so one thing to remember is, so if you're kind of struggling a little bit, x plus h means that you should replace each x in the equation for f of x with x plus h, which I think that's a lot to take in, but an example couldn't hurt. Okay, so I'm supposed to show that for f of x equals x squared, f prime of x equals 2x. So we're going to do a little bit of finagling, but we'll give it a shot using this difference quotient here. So I want to write down, so f of x equals x squared, and I want to plug it into my difference quotient. So in order to do that, I'm going to need to know what f of x plus h is. So f of x plus h means that you should replace each x in the equation for f of x with x plus h. So this part right here, that's the equation for f of x. And so each x I'm going to replace with x plus h, which gives me x plus h squared. All right, so then I'm going to multiply that out. So hopefully you remember, if something is squared, that means you multiply it by itself. So that would be x times x is x squared plus hx plus hx plus h squared. Okay, and then now I'm going to put it into my formula. So m equals f of x plus h minus f of x all over h. Okay, so f of x plus h minus f of x, I figured out what f of x plus h is. So I'm going to simplify this to be an hx plus an hx, that's a 2hx, plus h squared, minus f of x, which we decided was x squared, all over h. Okay, so the x squareds are going to cancel, which is nice. And then I have a 2hx plus h squared over h. So there's an h in each one of these terms, so I can cancel and get 2x plus h. So I think that's kind of interesting. We should come back to that. We were supposed to show that for f of x equals x squared, the derivative is 2x. Well, I got 2x plus h. So looking at our picture, that h is the second point. It's the second point on this curve. So if you imagine we're making that h smaller and smaller and smaller until it's exactly the same point twice. So if h is really small, we get 2x. So that's something to think about. Let's try number 5. So this time we're supposed to show, oh, I'm missing an f here. We're supposed to show that for f of x equals mx plus b, the derivative is m. So let's kind of see if we can put a whole bunch of stuff together. So this equation up here gives us the slope. The difference equation is giving us the slope. Earlier, in a different video, we talked about how the derivative is the slope. So we're going to try to use the difference quotient to get this idea out. So again, we have an f of x. Now we're going to think about what f of x plus h is, so we can use the difference quotient. And when we have an x plus h in here, we take our original function and replace every x with x plus h. And I always put parentheses, plus b. So I'll multiply that out. That's mx plus mh plus b. Okay, so then difference quotient, m equals f of x plus h minus f of x all over h. So plugging stuff in, I know what f of x plus h is, mx plus mh plus b, minus f of x, which was just mx plus b, all over h. Okay, so we have, oh, this is nice, mx on top minus mx plus b, ooh, oh, and I almost forgot parentheses here. That makes a big difference. Plus b minus a b. So those are going to cancel too. So I end up with, oh, this is super nice, mh over h, which the h's are going to cancel, and we get m. So this is nice. So one thing I did that was kind of sketchy is I used m to mean two things. Here I meant slope, and the rest of the case I meant the m and mx plus b. So I get then that using our difference quotient, that for mx plus b, the derivative is always going to be m. So this is good. That's really good. Okay, I think we should stop there. If you have any questions, please do ask. This is tough stuff, but we can do it. We can really do it. We'll do some practice, we'll do some labs, and please ask questions.